Thank you for joining XROM, India's first AR/VR focused podcast. And today, I'm delighted and honored to have with me Dr. Michael Grieves, who's considered the father of digital twin, a concept that he originated. Dr. Greaves has written the seminal books on product lifecycle management and the seminal papers and chapters on digital twins. He has consulted and done research work at some of the top global organizations, including NASA, Boeing, Unilever, Newport News, Shipbuilding, and General Motors. He's currently the executive director and chief scientist officer at the Digital Twin Institute. So, Doctor, really appreciate you taking time and being part of the podcast. Why don't we start with a simple and brief explanation of what digital twin is?
Yeah, digital twin is the ability of basically moving work into the virtual world. So we've had physical things since time immemorial, but as soon as we had an idea about it, we had to basically reduce it to physical form, draw a sketch, do blueprints, do a prototype, because we have a inability to share that with other people. What the digital twin is the ability of taking that information that we have and basically creating a digital version of it, so that we can look at sharing that information. And by the way, then we can model and simulate it to see how it's going to go about into the world in terms of being able to behave. The digital twin consists of three things. We have the physical environment and the physical objects we've always had. We now have digital objects in a digital environment that are courtesy of our computing capabilities. And then we have a connection between the two. We want to take data from the physical world to populate the virtual world. And then we want to use information that we generate and go back into the physical world. And why do we want to do that? Well, because information is a replacement for wasting resources. And so we would like to make all our mistakes over in the virtual world, and only when we get it all right do we want to go out and move around expensive atoms. And computing capability keeps getting cheaper every year by virtue of exponential increases in computing capability, while physical assets get more expensive by at least inflation, which has been a big problem in the physical world. So we have a divergence of costs, and so we'd like to basically be able to use the digital virtual world in order to be able to develop our product, test our product, manufacture our product, support our product. And only when we get that all right and make all those mistakes that we would make in the physical world do we basically go out and move around expensive atoms.
Right. Thank you for explaining that, Michael. So, I mean, over the years, we've always made copies of physical objects, I mean, in the forms of blueprints. But right now, what we're doing is we adding the layer of data to it, real-time data, through which we can process and understand what through the simulation, how these twins of a physical copies are behaving, learn through it, and iterate so that we can build products, better products. Can you kind of give us some examples of the ways how digital twins has been leveraged for businesses, leveraging digital? How is that added value?
Yeah, so basically, it's pretty expensive to do things physically, and it takes a lot of time and effort. And let me give you an example, a recent example from NASA. So NASA is building a new moon rocket, the SLS, that's going to take us back to the moon. And part of that was to build a hydrogen tank. Well, they built a physical hydrogen tank that is basically 400 feet in size. It's huge. And they wanted to make sure that it could withstand the forces it needed. And the only way you really do that is to test things to destruction. So they took this tank and tested destruction, hundreds of millions of dollars and months of time. And there's a great video out there about how that happened. Well, they basically did the digital analysis of it, basically a digital twin, and that took a few months and cost millions of dollars. So in just that simple example, it kind of shows how we can use the digital arena do that. By the way, we were within 3% of the amount of pressure it took to destroy that tank, and they identified exactly the place where it was going to where the weakness was. The examples abound. I mean, in the airplane manufacturing, one of the things you do is you bend the wings till they break, and that's a very expensive test, and it takes all kinds of equipment. Now they do that virtually. So in the past they used to have to do a few of those. Now they do one at the end that basically proves out that point. Crash test vehicles, but also, you know, I'll give you an example of one where the design wasn't right. Is that they were designing an airplane, and when they this is a little older technology, they went into a virtual cave and tried to connect the fuel line for refueling it to that design, and it wouldn't fit, and it was in the wrong place. Well, had they built the airplane itself, they would have had to spend millions and millions of dollars in terms of redoing the refueling thing. This fix was a minor fix because they hadn't actually built anything. But I can go over and over. We're looking at, for example, in the medical field, doing heart ablations, and so the physician gets a CT of the exact patient's heart, and then he tries different techniques to see which one is going to work. I much, as a patient, much rather him try it on my virtual heart or my digital twin heart than on me to see if that was going to be the case. So the examples abound, and there are huge magnitudes of difference between the costs of doing this virtually and the cost of doing it physically, especially when you're talking about human lives. You know, that's kind of priceless in terms of those making mistakes on humans versus making mistakes in the virtual world.
Right. So you gave examples of NASA's the moon rocket, hydrogen tank, airplane manufacturing, and you also gave an example of in the healthcare space. Is there any examples that you can share in the enterprise space? So the examples that you gave is largely of these like very big industries. Can digital twins also be leveraged by the small, medium enterprises, small businesses?
Yeah, I mean, and I think that's a really valid point. It can. The problem we have right now is the fact that the cost of them having that kind of capability and being able to put that in their own operation has been prohibitive. So one of the things that I've said all along is the large organizations currently, in a lot of cases, do all their things in a model-based environment and then have to dumb it down for smaller organizations who build the print. We're going to have the small to medium manufacturer be able to do that, and that means that that they cannot afford to have all the hardware, software, big IT staff. So we're going to need the solution providers to, in essence, sell by the drink, if you will, for the small to medium guys to do that. And we're starting to see that in terms of the major software producers to be offering that as a cloud-based environment. We've got some issues there in terms of security and understanding, you know, who owns the data that goes in there. But quite frankly, we have to be in a situation where everybody in the supply chain is going to be working with the same model-based data and information, as opposed to having to the old build to print. That's not going to fly anymore. The cost is just prohibitive.
Right. So you're saying at this point in time, you know, largely that happens with anything which is in the nascent stage. I mean, you know, so the cost becomes very, very prohibitive. But I hope that in the next few years, you know, the cost goes down and there'll be more and more companies leveraging digital twins, because metaverse itself, you know, the technology which I think will power digital twins is becoming big. There's NVIDIA's company has created a 3D engine called Omniverse, and they in fact have also created the digital twin of the entire Earth to simulate weather. So I'm sure there'll be more and more use cases which is going to seep into industries and the entire world. Now, if somebody wants to like start building an application, where does he start from? What's the process? I mean, if you can explain the process, it'd be very nice.
What's the use case? Where am I going to get value out of this whole thing? And you need to drive it from specific use cases. And then once you need to do that, then you need to look at not only the technologies that are available, but what are the cultural impacts in your organization in doing that. So, for example, let's take our small to medium manufacturer who's been in business for 30-some years, and you say, hey, we're going to go to digital twins. That is not going to fly. I mean, we need to kind of figure out how we're going to address that. And one of my suggestions is we have digital natives. I mean, people who have never known a time without a computer since their birth. They adapt to these things very quickly. So we're going to have to match those kinds of people with the individuals who have no idea what this technology is about in order to be able to do that. And we've done that once before. I mean, when computers first came about, the older generation had no idea what this was. And in fact, that's how I got my start when I was a teenager in computers, because I learned to program, and people, older than me had no idea about how that could work. So I think it's possible. We have issues. I think the universities are not doing a great job in terms of preparing our students to do that. So the technology issues, I think, are pretty handleable, and I think that they go along regardless of what we do. I think the big issue we have here in terms of this kind of adoption is cultural issues, and we need to figure out how we're going to basically move that into the smaller organizations.
We've seen a huge rush, post-COVID, where the world is kind of moving more, towards the digital, So my son is in a virtual school. I work for a company which is, remotely. I lead a team which is around 10, 11 members team. And it's a complete remote stuff. So, yes, I think that there'll be more and more push towards the virtual world, and these technologies such as virtual reality, augmented reality, mixed reality. When it kind of gets converges with 5G and AI, then it'll get more empowered. And you spoke to the education, the education institute needs to be a little bit more future focused and kind of understand where the puck is going to be at, and prepare students for the future rather than, they're going on and, with the same old syllabus. So I think that the world is really changing. I think what needs to change are these institutions, which are traditional old institutions. They need to see that the rate of speed of acceleration of these converging technologies, because these technologies are so potent that it can transform us as well as disrupt us. You are the chief scientist officer at the Digital Twin Institute. Can you talk about that and maybe some
issues? I think yeah, well, it's more of a sort of a virtual thing, and we look at opportunities in terms of advancing. So, for example, a big project I have right now, since you mentioned the metaverse, is I'm a co-editor of a book that's coming out called Digital Twin Simulation and the Metaverse, and how we're basically going to use that. And we're throwing around the term metaverse, and we really don't know what that means quite yet. So for those that are science fiction fans, I mean, Snow Crash defines a metaverse that isn't something that we could use because it doesn't have the same rules that we need. So we're defining right now what will a digital twin metaverse need to be, and how are we going to do that? And so is it immersive? I mean, do we have interoperability? I mean, one of the big issues that we're wrestling to the ground right now is okay. And if I have a slide that kind of shows where we are in terms of the advancement in the digital twin era. Well, I say we're kind of in the ad hoc version. We have digital twins, but it requires sort of people themselves to pull the right data together to develop their digital twins, and they're kind of using point solutions. We're going to need actual metaverse platforms where people can bring different digital twins and put them together. So, example I used is if we're building an airplane, we have a digital twin of the fuselage, we have a digital twin of the engine, we have a digital twin of the fuel tank, we have a digital twin of the wings. Well, when we basically fill the fuel tank with fuel, that not only has to register on the digital twin of the fuel tank, it has to increase the entire weight of the entire airplane. And so the interoperability of digital twins, I think, is our next big hurdle to move forward, so that we can put digital twins into, let's call it the digital twin metaverse, and be able to have them operate together, so that we're not doing things in a disparate fashion and then trying to hook them together. There are some examples. For example, the Abu Dhabi National Oil Company has built an entire digital twin of their oil fields, pipelines, and refineries. But they've spent hundreds of millions of dollars in brute force programming to make that happen. They've gotten great returns, but not everybody can afford to do that kind of work in order to create an integrated digital twin. And that's what we're going to need if we're going to move into the future capabilities of being able to have different digital twins come together and operate as if they were physical things.
I think in the next few years, I mean, almost all of our physical world objects, assets are going to be sensorized, and it's going to give us information through which we'll be able to do predictive maintenance and so on and so forth. Internet of Things. Would you be able to differentiate between digital twins and what Internet of Things is?
When I said initially, we have basically the physical world with physical products that send data into the digital world and the digital twins. Where's that coming from? I mean, that's got to come from basically sensors and communication. So back to my previous paper, I talk about that kind of capability. So IoT is critical in being able to censor the physical world and give us that data. The virtual world knows nothing about the physical world unless we give it that information. I mean, we live in the physical world, and our senses are the things that allow us to basically be able to traverse that world and understand what's going on. IoT is that connection for basically the digital twin ability. And the Internet of Things is kind of a misnomer. It's really the Internet of everything. So we need to basically censor everything, assuming we have use cases that are great value, to be able to understand what's happening in the physical world, to be able to model and simulate it in the virtual world.
Right. Yeah, I think in the next few years, we'll be able to sensorize almost all and everything around us. Now, AI is in the hype cycle. It's doing some crazy thing. The large language model is generative AI. What's the role that you see in digital twins when it comes to AI?
We basically have too much data, too much modeling and simulation to be able to have humans be able to deal with it. I'm not suggesting a human should be out of the loop, because I think that from my perspective, AI is not a replacement for humans. We have plenty of humans. We don't need any replacements, but they can assist us in basically doing the work. And if you look at AI, it's on a spectrum from smart calculators, to the Terminator. So obviously we don't want the Terminator, but we would like an AI system to be able to look at massive amounts of data and be able to give us probabilities of things that are going to happen in simulation. So there's a concept that I've basically promoted for a long time called front-running simulation. At every time zero, we get data from your IoT devices from the physical world, and we project what's going to happen from that device in terms of modeling and simulating that. And we then apply what I'll call Bayesian probabilities to come back to people to say, if you keep doing this, my predictions are that you're going to have an 80% chance of this problem occurring in 3 weeks and a 90% chance in 8 weeks. So who can do that? Well, we're going to need AI to basically be able to in essence traverse the solution space to be able to do that. I mean, one of the things that I talk about is what's the difference between us and nature. Now, we're goal task oriented individuals that try to minimize the use of resources for any task that we have. What does nature do? Nature tries all possible combinations and lets the environment sort it out. We can't afford to do that. Okay, needless to say, a lot of people would get killed doing that. But AI, its natural habitat is the digital world. So in essence, AI can try all possible combinations and come back and tell us, hey, these are the ones that have the best opportunity for success. So AI's natural habitat is the digital world, while our natural habitat obviously is the physical world. And so I think we can use AI in essence to explore the solution spaces of what's going to happen and be able to then give us advice or recommendations about what we should do to avoid having a problem. You know, Industry 4.0, the basis that has started, and I think they've changed that since my work, but it's been, hey, when we have a problem in a factory, what we want to do is reduce the time to remediate that problem. And in fact, there's papers out there that talk about that. From my perspective, I never want to have the problem. I'd like to predict that that I have a glitch in this robot that has occurred, in the morning, and by the afternoon, I'm going to have a bottleneck down on the assembly line. So I want that to tell me that, so I can go fix that and never have that bottleneck on the assembly line. And I think that's what I view this combination of digital twin simulation, metaverse, AI is a crystal ball into the future to give us a hint of what's going to happen so that we can get out in front and solve problems before they occur.
How cool is that? So you're saying that in the next few years, we'll be able to, whether it's large industries or whatever, we'll be able to predict things before it actually happens. So that's, sorry, you're saying something.
Yeah, I mean, you said the next few years. I'm not quite sure how long, what the horizons are, but we can do some of that today. I mean, I think it's going to be a gradual thing that allows us to say predict more causal things. So if this machine goes down, for example, I mean, it's going to be pretty obvious that I need to do something to do that, and it will predict what's going to happen. For things that there may be this happened over here and that happened over there, and that's going to cause a problem. That's a tougher thing, and you just have to use probabilities to that. But to your point, that's going to happen. I mean, we will have this crystal ball into the future. I just would prefer not to put a time frame on it to say in the next few years. Might be 5 years, might be 10 years. But if you look at the curve of computer capability we have, I mean, we passed 80 billion transistors on a chip,
right?
Fairly recently. I mean, my projection is by 2030, we'll have about 7 trillion transistors on a chip. Now, people are predicting Moore's law is going to the prediction that there is a doubling of computing capability every 18 months is going to slow down. But even if it slows down, we're going to have a phenomenal amount of computing capability coming online. And if we get quantum computing, all bets are off about how much computing capability we have. I mean, what I'm talking about in terms of all these different versions and being able to predict that, I mean, that's what quantum computing does. So that's going to be child's play. But at some point in time, we are going to have this ability that I'm talking about. Don't know if it's a few years, but it's going to come about.
Right, fair enough. Just maybe, I mean, if you could just open up that a little bit, the Moore's law, the ending of Moore's law, because you mentioned that the chips, right now we have somewhere around 80 billion transistors which are being stacked onto these microchips. But even now, I think we've gone to somewhere around the size of 2 nanoatoms or something like that, and the quantum effect might kind of play in. So that would mean the end of the the Moore's law, right? And then we don't progress further. We need to find other ways to compute. Obviously, there'll be quantum computing, which computes through the leveraging the source code of life atom. But that's a different computing paradigm itself. But a classical computing platform, but since there is no space, how do you assume that it's going to move ahead?
Yeah, and in fact, I just gave a talk at one of the major semiconductor manufacturers, and I think the thing is that jamming transistors onto a chip is not the only way. I mean, in addition to that line of things, we've done different things with packaging, with separating computations out. I mean, when I started off, you had just one mainframe system. Now you have racks and racks of systems that work together. So, the issue of it is that there are different technologies besides the classical. Let's see how many transistors we can jam on a chip to basically be able to increase computing capability. So, but if we go to quantum computing, I don't know that you need to do anything else. I mean, you're going to have massive amounts of it. Now, I think general purpose quantum computing is questionable, but I think you're going to see special purpose quantum computing for a special kind of problem. And so I don't necessarily know that we're going to flip a switch. You see these movies that basically now quantum computing has all the prediction of the universe out there. I don't know that we're going to see that, but I do think that we're going to see special purpose quantum computing, which again, since I like to drive things from use cases, would be kind of where I see kind of these sorts of issues getting solved.
Right. For brands and companies, new to the concept of digital twins, what steps would you recommend or suggest? Where do they start from if they want to get into leveraging digital twins?
Well, I think they first need to start from use cases. Where are they going to get their value? There's sort of two problems with this generational divide. On one side, as I mentioned, you have, and it's not completely bifurcated by age, but that's pretty much you're going to find a lot more older individuals who don't understand this than younger individuals. But the issue is going to be is that if the digital natives come in and say, look, I can create this great digital twin of everything, and it's only going to cost you hundreds of millions of dollars, it's not going to get approved. So it's got to be driven by use cases. So where are you going to get value from your digital twins? The thing with physical stuff is you either have all of it or you have none of it. You can't basically be able to say, oh, send me the outer mode line of your product kind of thing. With information and data, you can have it granular. So you can pick areas that are opportunistic. And I think you have to start with pretty high projects in terms of their feasibility. And so as I call low-hanging fruit. You basically have to look at those particular projects to prove out that you can do this sort of things, because I think the hype aspect of this also can overwhelm kind of our common sense about what we should be doing this for. So you gotta pick some projects, and then you've got to basically address the technology. How am I going to do this? But you also have to address the culture. Who's going to do this, and how reticent is my culture to making these kind of decisions? Do people feel comfortable dealing with the digital capabilities? I run into situations where people say, look, unless I can put my hands on it and touch it and put it in a press and crush it, I don't believe that this is going to work. So I think the biggest issue right now, I think because the technologies are coming on stream as fast as we can imagine them, I think the cultural issues about, how do we get people to engage in the change management necessary to do this is going to be kind of the big issue that organizations need to deal with.
Fair enough. How big is digital twins as a career opportunity? And if there are listeners who want to take this seriously, India, but globally, I think.
Well, I think that there's nothing sort of different about this capabilities that you couldn't go into, say, computer science, data analysis, probability, statistics, geometric design. I mean, I think that all those sorts of things are sort of digital twin oriented. In fact, I am with the University of Central Florida, and we're doing a survey about, you know, what are the sorts of things that the digital twin future holds for people that are looking in this. And I think that for example, you've got to understand what is the purpose of it. So simply being able to do the technology isn't going to work. You better understand how this product is going to perform. So you have to have subject matter experts or understand that in terms of hey, if I'm building an airplane, I mean, you know, I can put one in the digital world that I can basically make do anything I want, like go, you know, Mach 50, for example. But I can't do that in the physical world. So I need to understand how our physical world works so that the digital twins that I'm working on don't violate the laws of our universe that preclude them from not happening. So there's a combination of the technology, but also understanding what do my products really have to do? How do they create value for my customers? And, you know, is the technologies I'm talking about really feasible in terms of when I actually have to turn it into physical form? If I can't turn these things into physical form, all I have is pretty pictures on a screen somewhere, you know? So I really have to have the ability of being able to do that. But again, I mean, you're talking about all kinds of technologies that we are certainly equipped to deal with in terms of that. My issue, back to the educational institution, is I don't think we're basically preparing our students well enough to adopt these technologies. And in point of fact, you know, my suggestion is we should never send an engineer over to the math department to take a math course. I mean, you don't need to do 50,000 diffie-Q problems to understand differential equations. That needs to be part of the engineering curriculum. And quite frankly, they really don't have to do that. The computers can do that. They need to understand, you know, how those things work and what's reasonable. So if they come back and say, yeah, my answer is 10 to the 50th, you know, that's more than atoms in the universe. And so you need to understand, you know, what I call the gray boxing of this. I mean, what are inputs that come in? What are the outputs that come out? And are they reasonable to get there? But I think that we don't necessarily prepare our students to understand those sorts of things. And we need to do a far, far better job. In fact, the Digital Twin Institute, we're developing a syllabus for that.
Congratulations! That would love to see that curriculum and correctly pointed out. I mean, I think it's not just in India, but globally. I think, you know, the education system is failing, and they need to look at the future and where things are going, and make the students ready for the future, because that's not happening. If people want to reach out to you, how do they reach out to you?
Yeah, they can send me an email at two places: mgreaves@mwgvp.com or michael.greaves@UCF, University of Central Florida.edu.
Thank you, Doctor. Really appreciate you taking time and being part of the podcast. My last question to you: what comes next for Dr. Greaves, and paint a picture of what the world would look like once we have the digital twins that you speak about, which could make industries fault proof, where there is no you can avoid all errors, and, you know, maybe paint a picture or something like that.
Yeah, so I mean, I think that the next phase, and as I said, I'm working on a book right now that I'm the co-editor for, in terms of digital twin simulations in the metaverse. So defining what this metaverse is going to look like, and how do I get interoperability? How do I handle the cybersecurity of it? You know, do we do immersive things? What do those things sort of look like? Those are all kind of, I think, interesting problems that we need to look at. I am working with the Digital Twin Consortium, which is an organization that is focused on, how do we advance these in all these different industries. I came out of industry. I spent decades. In fact, had my own computer company, and technically I retired. I failed miserably at retirement, so I have no idea what I'm going to continue to do. But I think this is an area where sort of the sky is the limit, and maybe the universe is the limit in terms of the kinds of things that we can do. Again, I sort of say not only is it a technological journey, but it also will be a cultural journey. And I think how do people adapt to this is going to be an interesting perspective.
Thank you, Doctor. Really, really appreciate you taking time and being part of the podcast. I think we're sitting in a fantastic point of time where these technologies are converging. And in the next few years, decade, I think we will slowly transition to the virtual digital world where the metaverse is going to get more solid, where we're going to touch feel the virtual worlds, and it's going to be exciting because then there's going to be like these brain computer interfaces, then AI becoming more potent, where going from its narrow capabilities to possibly like a general purpose artificial intelligence, and all of these physical objects, it'll be sensorized, giving us details. I think that world can be really beautiful if we take the right steps and make sure that our data doesn't get manipulated, doesn't get hoarded, and institutions understand the future and create a world where it's more inclusive rather than the way it is, where it's more segregated and boundaries divide us. I hope that we get into a world which is more equal. Thank you once again for taking time and being part of the podcast. My listeners, if you like what you see in here, then please press the subscribe button. Until next time, see you guys. Bye-bye. Thank you. Thank you, Doctor. Really appreciate this.
Thank you.